Same concept. So some of you have been asking like how to do lah. So same thing. You can either use the classical method, or you can use the choosing method lah. So as long as you are choosing without replacement, I think this is choosing with replacement, or when you choose like that, this is without replacement. 12 counters from the back. Then the probability that there are 4 red counters among May's 12 counters is the same as probability that there are 3 red counters. Show that this one. Okay, so let's try and do that. Okay, so you have 4 red and 8 blue, then 3 red and 9 blue. These two are equal lah. Okay, because you chose 12 counters ma. So the easiest way is to use the choosing method actually, because it's going to be very complicated, but you can also use the classical way of doing it. So I'll show you how. The two methods are method 1. If you want to use classical method, it doesn't mean that you cannot do it, but it's very cumbersome. So that's why we prefer to use the choosing method. So method 1 is where you have 4 red here. So I'll just show you, this is 4 red. 4 red. Okay, then over here will be your 8 blue lah. Now when you do this, remember to multiply by 12 factorial over 4 factorial, then over 8 factorial. Then this is equals to, you do the same for the 3 red. So the 3 red, actually the good thing is the denominator will be the same lah. Okay, so this one will be like that. Then just be mindful, you have 3 red, there's 4 red, right? Maybe you just see, you do the same, then this will be 12 factorial over 3 factorial over 9 factorial. The good thing is that everything could be cancelled away because the denominator is all the same. So if you cancel everything out like that, sure. This one will cancel with this one. Okay, this one will cancel with this one. Then everything below will cancel away lah. Okay, what is left is the top and the side here. So you just write. But of course, this one can also cancel. Later we cancel it out. We just write it out. This is your 495 over here, right? Same thing, I'm going to key in 220. Then this is R minus 1, R minus 2, then B, B minus 1 to B minus 7, B minus 8 lah. Okay, this is, if you want to do classical method, it will work. Okay, so then you can cancel. Same thing, you can cancel. So it's quite fun. You cancel this one. You look at the this one R, this one. So it's left with this guy. So this one cancel all the way to this guy. So you're left with this guy lah. So you can just do that. There you go. Then this will be 9 over R minus 3. So 4. Okay, this is 2 marks. So sometimes 2 marks is basically their difficult question. So you don't have to sweat about it. Then I think this will get an answer. You see. So a lot of you try to do this method, but you all didn't do like very well. But this is the first method you're thinking about. We don't really like this method because this one is a lot like, but unless you can explain it properly lah. So this is method 1. But I will prefer this one, but I'm not sure if you prefer this one. But either way, you just make sure you whatever float your boat. So this guy will be, when you're using NCR, you don't need to arrange because by choosing you already account for it. Okay, so you're told that the probability of choosing the 4 red and 8 blue is the same as probability of 3 red and 9 blue. So essentially you can just write down because the denominator will be the same. You can just write this is just 4 red, 8 blue. The number of ways to choose 4 red and 8 blue is equals the number of ways of choosing 3 red and 9 blue lah. Okay. So this guy will be out of the R red balls I choose 4. This one out of the blue red balls I choose 8. Is it balls? They are balls, right? Counters. Okay, blue counters. Then this is R choose 3 times 8 choose 9. Then you just use your formula to formulate it. Okay. Formula will be R factorial, 4 factorial, R minus 4 factorial. Then this is B factorial, A factorial, B minus A factorial. Then this is R factorial, 3 factorial, R minus 3 factorial. Then this is B factorial, 9 factorial, B minus 9 factorial. Okay, that's it. Same thing, everything can be cancelled away. So this can cancel, this will cancel, this cancel. So that you can see why we prefer this method, because it's much easier. Okay, although it looks tough, but it is much easier. So then you just cross multiply to the other side. So actually you can also think of this is equal to this one because on top is 1, bottom, so it's 4 factorial r minus 4 factorial, 8 factorial, b minus 8 factorial. Okay, so like I say, factorial is very fun to play with. What you need to do is just take the bigger one and just so for example, this guy here, okay, this guy is bigger than this one. So we need is this is 8 minus, this is 8 minus 9. So you expand this, you can just 8 minus 10 and so on, but you just stop, you just minus 1, then you just put the factorial behind. So for example, if you have x factorial, this is x minus 1, x minus 2. So you just put a factorial sign behind when you stop your expansion. So similarly for this guy, this is the bigger one. So I'm going to put this as r minus 3, r minus 4 factorial. Okay, so this one can obviously cancel and become 4 here. This one can cancel, this will become 9. So I'm going to leave it there. So this will be 4, r minus 4 factorial. This is 8. Then this is b minus 9 factorial. Then this is just r minus 3, r minus 4 factorial, 9, b minus 9 factorial. Okay, there you go. Cancel this out. Cancel this out. Cancel this out. Cancel this out. Works as well. Okay, so there are two ways of doing it. You just make sure the factorial sign you know how to do, but if you want to do this one, also just make sure you expand properly. This one is a bit more complicated. You just be slightly careful how to minus it up. Part B, you read the question. So you have 3 rate counters among maze 5. Okay, so 3 rate counters is 5/3 of 2 rate counters being chosen. Okay, so 3 red and how many blue? Blue counters will be, because you 12, right? Then it'll be 9. Then this is 2 blue, 3 red. And then this is probably that 2 red. So 2 red, then you have 10 blue. So you just do, they say find the equation same with part A, then you just solve simultaneously. So it's the same thing. So for part B, do the same thing. So for this case, I'm just going to use the choosing method because that is much easier. So R choose 3 times 9, blue choose 9 is equals to 5/3 times over, okay, so same thing. I'm just considering the number of ways instead of the probability, because if the probability is the same, then the number of ways of choosing them is also the same. So 5/3 times and 2R and B. Okay, so this will be R choose 2 times B choose 10. Okay, that's it. Then you just expand. Then you just simplify. Okay, just simplify, cancel this one, cancel this one, cancel this one, cancel this one. Then this guy and this guy, this is r minus 2, r minus 3 factorial. Then this guy is b minus 9, b minus 1 minus 10 factorial. So just simplify again. My whole goal here is to make sure that I've got b minus 10 here, b minus 10 here, and then after which I can cancel all the way. Then I'll also want to make sure that I got r minus 3 and r minus 3 here. Okay, that's it. Then I can cancel. Then cross multiply. I'll just cancel this out. Cancel, 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 cancel. Then this will cancel and give me a 10 here also. Okay, then this will cancel, give me a 2, 3 here. So what's left behind is just 3b minus 9, 3, r minus 2 times 10. Okay, cross multiply both sides. Cross multiply. So these 3 can cancel away also. So what is left behind is just r minus 2, 5b minus 9. Okay, then you just expand and just use simultaneous. Okay, so here you go. 1 and 2. There you go. So you solve it. So from here, you solving 1 and 2, b equals 35, and then r equals to 15. They say thus the required probability, right? You want this is not an easy question. You want 1 red and 11 blue, right? So you have 15 choose 1 times 35 choose 11 over 50 choose 12 in total. Key in calculator, you should get answer. So it's 0.05155. 516. Okay, that's all. So I do this question, yeah.